Hi guys, we are going to do section 1-2. This warm-up is just asking what you did in your string lab in class. So everybody did the string lab in class and we're just trying to figure out what we found. So if we remember correctly, we had a circle that we made with different radius measurements, okay? So we had a radius that we made with our piece of string. What we did with that string after we made our circle, so we got the radius, we took our little compass, made sure it was the same length, and made our circle. Then we also took that string and we laid it along the outer edge of the circle, the arc length, okay? And then we drew an angle and then we measured it. And no matter how big your circle was, if this arc length was the same as the radius, your angles all ended up being the same size. Okay, they all should have been between 57 and 58 degrees every single time. Whether you had tiny circles or giant circles or anything, if you use that same proportion where your radius and your arc length were the exact same size with that piece of string, then that angle was the exact same size every single time, okay? So that angle between 57 and 58 degrees is really important. That's actually called a radian. So if you've heard of radians before, it's another way of measuring angles. So 1 radian is when your arc length and your radius are the same, okay? So we're going to learn about radian measure. So you can write an angle in degrees like normally, or we can write them in radians. So today we're going to learn how to go back and forth between radians and degrees. So a radian in standard position. Now this sounds messy, but it's exactly what we already know, okay? It's a circle with a radius of S, so that's like your string, okay? Your radius was your string, and it intercepts an arc length of the same string length, okay? So your radius is S, and your arc length is S. That's exactly what we did. We made the circle with the radius, and then we put the string with the radius, okay? All the same thing. Then that angle that it makes is 1 radian. 1 radian, so 1 radian is about 57 to 58 degrees. So a radian is much larger than a degree because it takes 58 degrees just to get to 1 radian. Okay, so degrees are tiny, radians are big. So if we're drawing our angles, we can have our initial side always on the positive part of the x-axis. 1 radian, about 57-ish degrees, we'll say. That's not bad. So that's 1 radian. 2 radians, probably about here. Okay, so the purple was 1 radian. The orange is 2 radians. And then let's do one more. What does 3 radians look like? 3 radians has got to be pretty darn close to that axis. That's 3 radians. Okay? So, we're almost at the x-axis. We're almost at 180 degrees. However, we're not quite there. So radians, 3 radians, is almost 180 degrees. How can we get to 180 if it's just a little bit more than 3? Okay, so instead of saying 1 radians and 2 radians and 3 radians, 3 and a little bit more. What do we know in math that's 3 and just a little bit more? 3 point something. Pi. okay? Radians are all based on pi because pi radians, meaning 3 and a little bit more, which is what's going to get us to that x-axis, is 180 degrees, okay? We don't measure radians in 1, 2, 3. We measure radians with pi because pi is what's going to get us all the way down to that axis, okay? So radians always have pi in them. If you see something with pi, it's going to be in radians. Degrees are what we do normally with 1, 2, 3, 4, 5. But radians we do with pi. So we're going to go back and forth. So pi radians is 180 degrees. That's what the whole conversion is going to be based off of. Okay, that standard, that pi radians, 3.1415, blah, 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 is 180 degrees. So these are your two formulas. Or it gives you your two ideas, okay? So pi over 180 and 180 over pi. So 1 degree is pi over 180 radians, and 1 radian is 180 over pi degrees. Because it's all based on 180 and pi being the equivalents. So it's not that bad, but you do need a calculator. All right, we are going to convert from degrees to radians. To go from degrees to radians, this is how I like to remember it. We're going to multiply by pi over 180 because we were going to radians, which means I need a pi in the answer. Okay, pi has to have, or radians have to have pi. So here's my 45 degrees. What I'm going to do is I'm going to multiply by pi over 180. When you're multiplying fractions, sometimes it's easier to make them all fractions. So if you want to put 45 over 1, it's a little easier to visualize, okay? To multiply fractions, you go straight across the top and straight across the bottom, and you multiply. We treat pi like we treat any other variable. So 45 times pi, you're not putting pi like in your calculator because you want pi in your answer and you don't want it to be rounded in any way. So all you have to do is 45 times pi is just 45 pi. So that just 45 pi. And then 1 times 180 is 180. The only thing you need to do is reduce it. Again, with your calculator, you just have to do 45 over 180. So if you use your calculator, you just do 45 ABC 180. And when you do that, you're going to be given 1/4. Okay, that's the reduced fraction. Don't lose your pi. You have to have a pi in your answer. So 45 degrees is pi over 4 radians. Just like with, just like with variables, you don't have to have the 1. You can, and I'm not going to fault you for it because at least then I know you were reducing the fraction. All that's good. But you can have the 1 if you want, but you don't have to. But pi over 4 radians is 45 degrees. That's it, okay? So let's look at 30 degrees. We can put it over 1 to make our lives a little easier to visualize. You multiply by pi over 180. And we'll multiply straight across the top and straight across the bottom. 30 times pi is just 30 pi. 1 times 180 is just 180. And then you're left to simplify. So 30 ABC 180. 30 ABC 180 is 1/6. Don't give me that as your answer because we're going to radians, so you have to have a pi. You don't have to have the 1, but you have to have the pi. So 30 degrees is pi over 6 radians. 270. Same thing. Let's put it over 1 and multiply by pi over 180. And then multiply straight across the top straight across the bottom. 270 times pi is 270 pi. 1 times 180 is 180. Reduce. 270, ABC 180. Let me test this because I don't think. When you do this in your calculator, 270, ABC 180, it gives you 1 1/2. We do not write radians as improper fractions. Do not give me, put it in red so you don't think you do it, 1 1/2. No. Now, you can either convert because you know how to convert, or your calculator does do it for you. If you just leave the 1 1/2 in your calculator and then hit second ABC and then enter, it gives you 3/2. Is 3/2 my answer? No, because you have to have a pi. 3 pi/2. So yes, you have to have the 3 and the 2. There was not a 1 in this case, so it's 3 pi/2 radians. All right, I need you to do these 315, 450, and 60 on your own. Those have to be done when you turn this set of notes in, but I'm not going to do them for you. You're going to do them right now. So pause me, do those, and then we'll move on. All right. Now we're going to go the other direction, okay? So we're multiplying 180 over pi. I'll do 4, 5, and 6 for you and leave those easier ones for you to do on your own. So let's start with 4. We are multiplying, because we're going the other direction now, right? We're going back to degrees. So I don't want a pi anymore. I don't want a pi in my answer, but I have a pi in my question. So if you think about it, with fractions, if you have something on the top and something on the bottom, they're going to cancel. So that's how you remember that you want to get rid of your pi, so you need it on the bottom. So 180 over pi is what you're multiplying by this time. It's just the flip of what we did before. Okay, so same idea. Straight across the top and straight across the bottom. Multiply the regular numbers and then just leave the pi's as pi's. Okay, so you can do 3 times 180 and you get 540. There was a pi, so put the pi over. 2 times pi is 2 pi. Again, when you have the same thing on the top and on the bottom, it cancels. So there's no more pi's, all gone. So all you are left with is 540 divided by 2, or 540 over 2. When you do that, 540 over 2, what are you going to get? 540 over 2, 270. 270 degrees. The pi's canceled, so they're like a non-factor when it comes to this. So don't let that scare you. All you really have to do is reduce a fraction. Let's do it again. Multiply by 180 over pi, because I'm going from radians to degrees. Straight across the top, straight across the bottom. 2 times 180 is 360 pi over. 3 times pi is 3 pi. What happens to my pi's? Bye-bye. So I have 360 over 3. Okay, so 360 over 3 gives you 120 degrees. Oops. Done. All right, last one that I'm going to do with you. Multiply 180 over pi. This is negative. What does a negative mean? All it means is you moved in a negative direction. Okay, don't lose the negative. We still have to account for that, but don't let it stress you out. So if you do negative 5 times 180, you get negative 900 pi over 4 times pi, which is 4 pi. All right, what happens to your pi's? Bye-bye. And then negative 900 over 4, or negative 900 divided by 4, is negative 225 degrees. That's it. You could do the first 3. You need to do the first 3 on your own. So again, when you turn these in, these 6 that I did not do for you need to be completed. And then your homework is just the 1-2 worksheet. All right, bye guys.